Hello friends, hope you're doing well. Welcome to the 22nd episode of the SAT series. In this session, we are going to talk about a very important concept related to polynomials, and that is often tested on SAT and ACT. So it's important to know about that and to be able to use that effectively in the test. And that concept is nothing but basically a remainder theorem and factor theorem, right? So let's understand what these two rules or theorems so-called are, and how can we leverage these concepts to avoid doing any kind of a synthetic division or long division on the test. So let's do a deep dive on remainder theorem. Okay, so what's a remainder theorem? A remainder theorem says that if we have a function fx, right, and if we divide, when we divide that function fx by x minus c, or another polynomial or binomial x minus c, the remainder would be given by f of c. Okay, let's take a quick example. Let's say that we have a function fx equal to x square minus 5x plus 6. Okay, and we want to find the remainder when this function is divided by, let's say, x plus 1. Okay, so we have this function fx is equal to x square minus 5x plus 6, and we want to find the remainder when this function is divided by x plus 1. All we got to do, or what the remainder theorem is saying, is that when we divide this function by x plus 1, the remainder would be given by f of minus 1. So we can find f of minus 1, and whatever we'll get will be the remainder when we will divide this function by x plus 1. So let's see what is f of minus 1. So f of minus 1 would be minus 1 square, which is 1. Minus 5 times minus 1 is 5, so plus 5 plus 6, which is equal to 12. So essentially, what the remainder theorem is saying is that when we divide this function x square minus 5x plus 6 by x plus 1, the remainder would be 12. Let's take a quick example on the remainder theorem, right? So let's say that we have a function fx given by minus 4x cubed plus 12x square minus 15, and we have to find the remainder when this function is, let's say, divided by x minus 2, correct? As per the remainder theorem, what we said was that when this function will be divided by x minus 2, then the remainder would be given by f of 2. So essentially, we have to find f of 2. In this question, what would be f of 2? Just plug in x is equal to 2, and we get 2 cube is 8 times minus 4 is minus 32, plus 2 square is 4 times 12 is 48, and then minus 15, which gives us 1. So essentially, when this function is divided by x minus 2, the remainder would be coming 1, right? Now let's expand this remainder theorem a little beyond. Let's say that instead of this minus 15, the question was minus 16, right? And the same question, now this is the function, and we have to find the remainder when this will be divided by x minus 2. Again, we have to find f of 2, and f of 2 would be, in that case, 0. Correct? Because f of 2 is 0, so the remainder would be 0. Basically, what we are saying is that x minus 2 is a factor of this function, correct? Because if the remainder is 0, then it makes x minus 2 is a factor of this. Now we know that if x minus 2 is a factor of this function, we can essentially write the whole thing like this. X minus 2 times some entity is equal to minus 4x cubed plus 12x square minus 16, correct? If x minus 2 is a factor of this function, it means that x minus 2 can be multiplied with some entity to get to this, right? That's the meaning of factor, right? If we say that 8 and 4 are factors of 32, it means that 8 times 4 is equal to 32, correct? So now, if we are saying that when this function is divided by x minus 2, we get the remainder as 0, which we just saw, or in other words, we can say that x minus 2 is a factor of this function, we can write this, correct? Now, what is the value of this left side when x is equal to 2? When we put x equal to 2, the left side becomes 0. Left side is obviously equal to the right side, hence what it means is that when x is equal to 2, the right side will also be equal to 0. Right? If we try to connect the dots, what are we saying? We are saying that if x minus 2 is a factor of any polynomial, then the value of that polynomial for x equal to 2 will be 0. Correct? So basically, if we get a question wherein we are given a big polynomial, and if we have to find whether something is a factor of that polynomial or not, we don't need to do the long division, we don't need to do the synthetic division. All we can do is to find the value of that polynomial for the value of x and then see if it is 0. If it is coming out to be 0, it means it's a factor of that polynomial. We'll take a few examples to see what we are saying here. Okay, let's take an example here. Find whether p minus 2 is a factor of this polynomial p to the power of 4 minus 8p cubed plus 10p square plus 2p plus 4. Right? Again, very simple. All we got to do is to find the remainder. Right? If the remainder is 0, then it means it's a factor of this polynomial. And we just saw that by the remainder theorem, we can find the remainder by putting the value of p equal to 2 in this function. So essentially, let's find the value of this function for p equal to 2. Right? So 2 to the power of 4 minus 8 times 2 cube plus 10 times 2 square plus 2 times 2 plus 4. 2 to the power of 4 is 16 minus 8 times 8 is 64 plus 2 square is 4 times 10 is 40 plus 4 plus 4. Right? And if we add all of these, we get 0. So what it means? It means that when this polynomial or this function will be divided by p minus 2, we will get a remainder of 0, and hence it means that p minus 2 is a factor of this polynomial. Okay, let's take another question here. If x minus 2 is a factor of this function, a times x cubed minus 2x plus b times x square minus 5, find the relation between a and b. Again, pretty straightforward as we discussed so far. If x minus 2 is a factor of this function, then the value of this function for x equal to 2 should be equal to 0. So basically, suppose this is fx, right? Then f of 2 should be equal to 0. Let's see what it means. So f of 2 would be a times 2 cube is 8 minus 2 times 2 is 4 plus b. 2 square is 4 minus 5. Or in other words, it becomes 4a minus b is equal to 0. So this is the relation between a and b if x minus 2 is supposed to be a factor of this function. Again, just to reiterate, if x minus 2 is a factor of this function fx, then f of 2 should be 0. That's what we did. We just plugged in the value of x equal to 2 and found f of 2 and equated that to 0. That gives the relation between a and b. Okay, let's take one last question here. So if fx is given by this function 3 times x square minus 3x over 2 minus 4 minus 8 times x minus k, this whole function, if this function is divisible by x minus 3 over 2, right, we have to find the value of k. Right. Again, going by the factor theorem or by the remainder theorem, if this function is divisible by x minus 3 over 2, it means that f of 3 over 2 should be equal to 0. Right? The value of this function for x equal to 3 over 2 should be equal to 0. So let's find the value of f of 3 over 2 and then put it equal to 0 and get the value of k. So f of 3 over 2 is nothing but 3 3 over 2 whole square is 9 over 4 minus 3 over 2 times 3 over 2 minus 4 minus 8, 3 over 2 minus k, right? This and this cancel because this is like negative 9 over 4. So we're left with only minus 4 here. 3 times minus 4 is minus 12. This also gives us minus 12 plus 8k, correct? Which is equal to minus 24 plus 8k. So this is the value of f of 3 over 2, right? And if this function is supposed to be divisible by this, then this value should be equal to 0. Hence, minus 24 plus 8k should be equal to 0, which gives us k equal to 3. Hey friends, hopefully you liked the video and it gave you a good perspective in terms of what is a remainder theorem, what is a factor theorem, and how do we use them on SAT and ACT, right? Keep practicing. In case of any questions, please feel free to reach out to us at info.mathleaks@gmail.com. Do like and subscribe. See you in the next session.